So here I'm looking at 1.5, day 1 of the coordinate plane, where we derive the distance formula and we use Pythagorean's theorem to do so. Length is essentially just using the distance formula. Midpoint is a formula we'll go over, and slope of a line as well, line segment. So I'm going to skip through this and just kind of get straight to the point. This is how we derive the distance formula. We start by using Pythagorean's theorem, which we know is a squared plus b squared equals c squared, where c is the hypotenuse, the longest side, or the side that is opposite of the right angle. So what we'll do is we'll be looking at this specific triangle here, and it shows coordinates. The coordinate of A is just generalized as x1, y1, and then B is generalized as x2, y2. And then we can plot this point C right here, which we know, since it's directly horizontal of A, that we should have the same y value, right? Because it's not higher up or lower down, right? It's the same y coordinate as A. But if you look at B, notice that it's completely vertical, so it's not further to the right or further to the left. Instead, it is the same coordinate, x coordinate, as B. So we can say the coordinate of C is x2, y1. We can write an expression for each distance. So as I showed earlier, Pythagorean's theorem, a squared plus, I'll use orange here, plus b squared equals c squared. So kind of highlight these. Our b we'll just say is this leg of the triangle, although it does not matter which leg you use for a or b because you're doing the same thing to both of them. You're squaring them and summing them. So if you look, let's assume this is the side A. A is otherwise, in this case, line segment AC. So AC is the distance from this point to this point. And since it's just a horizontal line, all we have to do is take the x-coordinate from the C point and subtract it from the x-coordinate from the 1 point. So we get, make this bigger, x2 minus x1. Okay, that's AC. B, on the other hand, would be this side, the other leg. And if you notice, it's just vertical. So we don't have to worry about the x values. All we have to worry about are these y values. Now if we wanted the distance, which is just vertical, we would count these squares on the grid, but we don't have a grid. Instead, like we did with x2 minus x1, we will just take the y coordinate of the B point and subtract out the y coordinate from the C point. And that would give us the distance between those 2 points. So why did we do all this? Well, we know that AC is our A in this case. So we can say AC squared, I'll keep this black actually, plus, and what is our B in this case? Our B is this one right here. Do that orange. So we have, make this bigger too. In this case, this is BC. So we're just writing Pythagorean's theorem, but instead of using A, B, and C, we're using the actual line segments that compose this triangle. So what do you think is going to go right here? Which line segment? C. we're going to use c. So we'll do c is actually written as ab. And of course we're squaring this. This is Pythagorean's theorem right here. And what we'll do is we will replace these values for what we said they're equal to in these generalizations. So we know that AC is also equal to x2 minus x1. And we know BC is y2 minus y1. And we know that AB squared is just, we'll just use AB squared. Because in this question it actually asks us to write an expression for the distance of AB. So we'll keep AB as is. Now, really the last thing we need to do here to kind of derive the distance formula is just get AB by itself. And since AB is being squared, we should take the square root of it. Because if we did that, we would end up with just AB. So if we did it to the left side, we need to do it to the right side. We get this. And I'm just going to rewrite this whole thing in black. So we get the square root of x2 minus x1 plus y2 minus y1. This is still squared. So this is actually the distance formula. This tells us the distance from point A to point B using what is actually the horizontal change and the vertical change between those 2 points. So I'll just rewrite this down here. The distance formula gives us this generalization. This would be like A and B, and we're just trying to find the distance between them. In which case we can write just as D, as in distance, is equal to, what did we write? The square root of x2 minus x1 squared plus y2 minus y1 squared. Cool. And I think there's an example here in the notes, here, right here, length, that we'll go over briefly. So I'm going to start out just by doing the length and not worry about the midpoint and slope. We'll save that for another video. So we have M, which is located, I'm going to kind of plot this out so I can visually see this. Negative 15, so that's all the way down here. Positive 8, so that's like right here. It's just an estimate. And then N is at negative 1, 12. So there's N. So if we wanted to find the length of this segment, we would just find the distance between those 2 points. So distance is equal to the square root of, we're going to take x2 and subtract x1, right? This is written right here. So let's say N is our, I'm going to write this down here. This is our x1. x1, y1, that's our first point. And then N, which is negative 1, 12, is our second point. So I'm going to write x2, y2. So we can just fill this in, and it'll help us find the distance. So x2 minus x1, in this case, our x2 is negative 1. I'll take that. And we are subtracting x1. So our x1 here is negative 15 minus negative 15. Okay. And then our next part is y2 minus y1. So what's our y2? It's 12. So 12 minus, and what's our y1? 8 minus 8. So let's simplify this. I'm going to zoom in so my handwriting's a little bit better. Well, negative 1 minus negative 15 is negative 1 plus 15. So we should get 14. And then 12 minus 8 is just 4, so we have 4 squared. Now we know this is equal to, what is 14 squared? I forget. It's like 1. Oh. There you go. 196, okay. So we have 196 plus 16, which would give us 212. So the square root of 212, which is approximately 14.5. 0.56 we'll leave it at. So that's the distance between M and N.